Okay, welcome everyone to the IXUS 2026.1 release webinar. So in this release, we have the modeler version 4.18 and also for the modeler. And then this release includes a lot of features, some of which are highlighted here. So starting with copy-paste antenna configuration, which is a huge time saver when working with multi-sector sites. We've also added a KML import support, enabling you to bring in geometry from Google Earth and other GIS tools directly into the modeler. The Exclusion Zone Export has also been expanded into multiple formats, including KMZ for Google Earth visualization. So we'll touch on this on the demo as well. We have also added a CSV import and export for the segment attenuation. So you can make your own templates and making it much easier to work with standardized configurations. And then on the manager and the portal side, the portal has been fully rewritten on the back end. And this introduces support for confidential antennas and also improved data compliance. And then, we can also touch on that in the demo. So going into the features in a bit more detail. So starting with the copy and paste antenna config. So this addresses one of the most common workflows our users encounter, which is updating multiple sectors with a similar or same electrical configuration. So previously, if you had a base station with multiple sectors sharing the same antenna model and the electrical properties, you would need to manually configure each one individually, or you could duplicate one, but then the physical properties would also be duplicated. So now you can simply right-click an antenna and then select the copy config, then paste it into one or multiple antennas. An important detail is that it also copies the antenna model, but preserves the physical properties like the height, azimuth, and mechanical tilt. So this means that each sector can keep its unique physical orientation while receiving the updated electrical config. So this feature has also been integrated into the bulk antenna editor, so you can use it while editing multiple antennas in that view as well. Then we go on to the exporting of the exclusion zones. So the support has now been expanded to include multiple formats. As you can see here, the KMZ import is especially exciting because then it allows you to visualize your IXUS exclusion zones directly in Google Earth. So this means you can overlay your compliance zones on a 3D rendered geometry, which we will also see. And the way to access this is still the same. So you go into File, Export, and then Exclusion Zones. Then you will be met with a drop-down. Then you can choose. Then we go into the segment attenuation. So previously, you would need to define each of the segments for each of the antennas and each of the frequency bands. Now you can define it once and export that as a template and then import that for wherever you need that, either on the same site or across base stations. It becomes a standalone CSV template. Then going into the importing geometry from KML. So KML files are standard format used by Google Earth and many other tools. So this import maps KML features into equivalent modular geometry, as you can see here. So the points on a KML become a marker, a line string on a KML become a polyline, and so forth. So also the marker editing capability lets you modify the imported markers, and then also the markers can be turned into field points later, which brings potential for new workflows. Right, then we also have some smaller but impactful enhancements in this release, starting with the marker properties. As I mentioned, you can right-click and then make it a field point, or it also has a description part in it now that mimics the field point UI. The lobe imprint feature has been enhanced with mesh quality selection. So previously, you could choose when you run the simulation, fast, medium, or slow. The same options are now available when doing the lobe imprint as well. The bulk antenna editor also received some improvements, including the duplicate option, better auto resizing of the columns, and then the whole drop-down menus, and also input validation. And finally, the polyline guidelines have been enhanced in a way that it renders much better and the libraries also function. Right. Other IXUS development, which is not manager and or modeler. So the full IXUS portal rewrite. So the antennas are now much faster to download. It allows you to select the antennas and then downloads them as a zip file. The zip file can be uploaded directly onto the manager as well instead of uploading individual antennas. Also, the confidential antenna models are now much easily accessible. So instead of reaching out for each one, depending on your access group, you will be able to see the different antennas. And there's also an enhancement made on the DXF generator. So that's version 1.2 now. And then when we come to the demo, Martin will be able to go take us through that. And then also based on a lot of user feedback and the tickets that we receive, there's a lot of bugs that we have patched in this release. So blueprint crashes, label visibility, the area minimum measurements, along with the rest have also been patched as part of this. Okay, then we can go on to the demo. Just a quick overview of the different parts that we'll be touching on the demo. So we'll look at the copy paste antenna config, the import, and also the export to KMZ. Then the segment attenuation, how to make a template, and then the globe imprint as well. Right, I've now switched my screen to show the modeler.
Yeah, we can see it.
Okay, thank you. So yeah, just a quick view on my current base station. This is one of the piers in New York City, and the antennas are located here. So firstly, I'm going to start by adding a bit more detail onto this. That's my use case. I've modeled this part, and then I see there's neighboring structures that need to be modeled. So the traditional way is obviously you can trace this, or if you have measurements, you can draw them individually. But because of the KML import feature now, we can look at other tools such as this one. So here I've zoomed into the same area which I'm interested in. This is the part that is modeled, and that is my area of interest. So the highlighted buildings here will become polygons into the modeler eventually. This is just a free tool that I found, and it allows you to export a certain area as a KML. The key thing to note here is that this area shouldn't be larger than 500 by 500 meters, or the contents of that. So if you see, this includes buildings slightly outside. So when trying to import that, the modeler will prompt you to say that your geometry is beyond what it can accept. So hence I've just chosen the area of interest instead of zooming out too much. So once I've exported the file, I can open that same file on Google Earth. And this is the file that I'm interested in. So if I show that, here you see all of the buildings have become highlighted as paths or polygons. Once we expand this, you can see there's the different objects. And then the first one is a pin that becomes my reference point. I've just intentionally renamed that to be aware. So when I go on to the modeler, I can see where my reference point is. So this aligns with where ground is on the modeler. Okay, so once I have this, I can go onto the modeler, I can go File, Import Geometry, select that option called KML, and then browse through the ones that I want to import. So this is the one that I want to import. Here I'm met with a dialog box that looks like this. The first option is the latitude and longitude. So that is just asking for what is my reference location, and the reference location is the first pin that was on the KML file, which is this one. So here I can just double check. So because it coincides with ground, the modeler automatically prompts that. the first point on the KML file is the one that the modeler prompts, and then that is what I'm interested in. And here I see this 1 point and multiple polygons. So if I say OK, and then I show the geometry, this is the parts that were imported onto the modeler. So this makes it much easier to add details around the site. And yeah, initially this data source that I've chosen only has 2D objects, so that's why it's all flat. But for this case, let's say this needs to be that height, this needs to be that height, but these two only need to be that high. Okay, and the other areas are a bit too far for me in my case, so I'm not going to sweep them up or add any 3D elements to that. Right, so now I've done the modeling, I've done the assessment, and I have exclusion zones. What we can do now is we can export these exclusion zones into a format that is also viewable on Google Earth. So if we see File, Export Exclusion Zones, we are met with this dialog box. And then we come here and then we see the various options that are available. So the DXF was the initial or the traditional one. And now we have KMZ and other options. So in this case, I will choose KMZ. I am going to call this. And then I can save this. So when I hit save, it asks me for the reference location. And because my ground marker and the marker that I'm using on Google Earth is documented here, I can either just type this in, or if I have it copied, which you can fetch from here. So I'm just going to copy this. And I can say OK. And then it tells me that the exclusion zones have been exported successfully. All right. Okay, now I'm going to open the file that was exported. So this is the one that I exported just now. I'm going to open this. And if we see here, let me take the first one away so that we can see it in more detail. I'm also going to enable 3D and terrain. Right. And then if we come to this, we'll see the exclusion zones that were present on the modeler. Can also now be viewed on Google Earth. So obviously we only see the blue or the outer one right now. But if we expand this, we can see that it's made up of different things, starting with the antenna. If I zoom in, I'll be able to see there's an antenna here. And then I can take that layer away, take the outer zone away from the perspective. So then we can see the yellow zone, and then we can take that away to see if there's any 10x zones. Okay. So while we're still here, the interesting workflow that now can happen is, let's say you have on-site measurement data in a file where you have different positions of measurements taken. So you have position 1, position 2, and position 3. And here I have P0 just for reference. That's still the same coordinate that was used previously. I can save this as a KML file, and then I can import that same KML file onto the modeler. So we can quickly show that. File, import geometry, KML, and then it is this one. So here you'll see there's no polylines or buildings. It's only 4 points. And then there is my first P0 coordinate that is being pulled. And then if I zoom in, or if I take away the blueprint, you'll see here there's the P1, P2, and P3 positions. And then There's my P0. So if I double click P1, you'll see there's a description, and that currently says 25%. So that is the description that was imported from here. So this is just values that I am going to demo with. This is not actual values, but the use case could be if you have actual on-site measurements, you can right click and say create field point. And then it will retain that imported description that came from the KML file onto the marker and make a field point out of that. So this could be a very interesting way to overlay on-site measurements with simulated measurements. Right. Just hide P1. There is my point. Okay. Then we've touched on the few points of the demo now, which is the importing from the KML file, exporting exclusion zones into a KMZ file, and then the integration between Google Earth and the modeler. On that basis, we've also seen that markers can then have a description field and also XY locking. So if you want to move or position the marker in a certain way, you can lock a certain direction and then it will move in the other two axes. And then we've also converted the field point, or not converted, but created a field point from a marker by a single click. Now we can go into the antenna copy and paste. So let's say I've worked on the site. This sector is getting a different antenna model. With the following config. Okay, so this is what's changed. The physical part of the antenna hasn't changed. It's just azimuth 200, but the actual model is now different from what it was. So now if I'm updating the other two sectors, previously I would need to go into the other one and then re-enter the same thing that I entered here. But now I can say right-click, copy configuration, and then I've copied B2, and I can either choose A2 and paste config, or I can say A2 add C2 and then paste config. So here we see A2 also retains this, whereas previously this is what it was. So if I redo again, and I can see A2's internal config, including the antenna model, has been matched with what was P2, but the outer part, the tilt, the azimuth, the height, remains what was previously defined on A2. So the same is also available on the bulk antenna editor. So this is the physical properties. If you go into details, if I add, let's say, another frequency band on A2, and then I can copy this config and paste it onto P2. So there we see, and then I can right click, paste it on C2. So this makes it much easier to duplicate the properties of the antenna without having to duplicate the actual antenna and then manipulating both. In this, it just carries over everything that's on this, which is the model, the frequency bands, and the config. All right, so then we can move on to the segment attenuation. So if you have segment attenuation enabled, currently or previously, you would have to define the segments for each frequency by going into the dialog box, adding each segment, defining the segment, going back, doing the same thing for the different frequency band. What is possible now is if you have a pre-existing template, you can import it, like I have it here. So this is what it gets imported as. Or the first time when you come into this, you can define like you did previously. 2, 3, so this will be minus 90 to 45. Right, so let's do these two, and then I can say export, and I can store it locally. I can say, okay, here, move on to the next one, and I can import the one. So this makes it much easier. You can define it once and then use it either across this side, or that local template can be shared, and then other users can also use the same thing if it is a very common use. Right. Okay, then, so currently, if I'm going to run a simulation, I will be met with the three options, which is fast, low detail, medium, and then slow, high detail. So by default, it's medium. I can run the simulation with these settings. And then if I want to create a lobe imprint, I can also see these three options now. So by default, it's medium, but I can go into fast, and then it creates a lobe imprint. So this just gives the user much more functionality in terms of balancing detail versus speed. Okay, so that's it from a demo on the modeler side. And then we can go on to the manager and or the portal related updates. So this is the new look of the IXUS portal. All of the important options are still in the familiar places. So you have the help desk here, and then you have the antennas, which is currently open. And it is, you will be able to see, depending on access groups, what antennas you have access to, and then the ones that you have. Okay, I see there's a hand from Kelly. You're welcome to type your question on the Q&A side, and then we can get to that. All right, but in the meantime, yeah, so let's say these are the antennas that I'm interested in. I can say download selected. And there is my zip file. So this is the zip file. It has all of the antennas that I had selected. And instead of having to upload each one individually, I can go onto the manager. Into the admin tab, antenna models. And then I can just upload the zip file. Right. Then when we come to the help desk, that is a very familiar look and feel. So you have the tickets. Next to the tickets, you have the knowledge base. And if you go into releases, you'll see for this release, we have already published the release notes, which is much more comprehensive, and it's going to be available to everyone. We'll also add the recording here. And then going on to the Terrain DXF generator tool, I'm going to hand over to Martin for a quick demo on that.
Hello, everyone. Okay, let me just share my screen. Yusuf, can you just confirm if you can see my screen?
I can see it.
Thanks. Yeah, so there's just a few, I would say, minor enhancements that have been made to the terrain tool. So some of it is linked essentially to the modeler features that we've also implemented, specifically the KML import feature. So the main change there was made is when we do generate a obviously we have now a location and an area. If we generate that, it already created a location.kml file in the past, but now it essentially moved the center marker to the top of the line of the file, which makes it much easier to import that file into the modeler, because it automatically assigns the center location as the reference, which would be ground. And if we generate the DXF file and we go to the modeler, so now if we go import geometry KML file, let me just, it should be here, yeah, location. And that would just be the polyline and the point. So it would create this, essentially the frame of the area that I'm looking at. And if we go over here, if we just hide or just look at the bottom, you'll see the center marker is going to be the reference point that automatically gets assigned. I think I probably skipped over that part. So if we choose location, you'll see that this reference lat long is already inputted automatically. The other change that was made is simply a let's call it a rounding accuracy that was made in terms of the translation between coordinates and X, Y, Z, because obviously a KML file is like global coordinates that it's using, where in the modeler we are using X, Y, Z coordinate system, and the translation between those two things have just been improved in terms of accuracy to match, to more closely match what is being used by the import functionality of the KML as well, because that also needs to use the translation. The other change that was made was simply in regards to the API data sources, in which case the GPXZ elevation API key or selection has been changed. So previously it was a free and a paid tier. However, due to changes to the policies of that data source, we've now included it as only one option. And we've also added this section just to note that it is the user's responsibility to review the terms of service of the data sources that they are using. In this case, the one that was a little bit changed since the previous time we made this tool available was the data source that had some changes to its policies. And that's effectively it, what I wanted to demonstrate on my side. Thank you, Yusuf.
Okay, thank you, Martin. Yeah, there's a question in chat. So with this 3D port export, will it slow down the overall analysis calculation time? So I think only when you click on export is when it starts that process. So before that, this just as usual. And then currently the antenna XY coordinates are not exported. And then replacing the antenna, would that delete the frequency power table already? Yes, it will overwrite what you are pasting over. So essentially it's when you copy the antenna config, it copies that entire model and all of the frequency band, and wherever it's pasted, it will overwrite what was there previously. Okay, so some of you might have upgraded to the latest version already. If you haven't yet, you're welcome to reach us through our support channels, and then you can also give us feedback on the release. And like I said, the comprehensive release notes are available on the help desk. Right. Yeah, I think if there is anything, please do reach out. And this brings us to the end of the webinar. Thank you everyone for attending. Thank you, Martin, for the assistance. Right. Have a good day. Bye-bye.
Thank you very much.
Bye.
Bye-bye.